So now this video discusses about the variance as well as the standard deviation as also part of the components of the measures of the dispersion. So last time we talked about the measures of the dispersion, and that consists of the following components. We talked about the range. So range is one of the components of the measures of the dispersion. And we also talked about what we call as the mean deviation. We also talked about what is a mean deviation and how do it depicts about the measures of the dispersion. And today we want to finish out by looking at what we call as the variance and also what we call as the standard deviation. That is for grouped and ungrouped data. So keep that in mind. So in case you missed these actually things that is about the range as well as the mean deviation, just have to go through my video playlists on the YouTube channel and TikTok as well as the Instagram and even Facebook as well. You come across all these things. So it should be that. So what is variance? Now if we say a variance, that is said to be the average of the squares of the mean deviation. Actually I should say the average squares. Actually I should say the average of the squares of the deviations from the mean. That is what we call as the variance. So this is said to be the average. Let me have it. The average of squares should be of squares of deviations are actually from the mean. That is what we call as deviations from the mean. That is the definition of the actual variance. And how about the standard deviation? A standard deviation, by the way, the variance is symbolized as a sigma. So that is the symbol for the variance. It is symbolized as the sigma square. And while the standard deviation, so standard deviation, you know that is so a standard deviation is symbolized as just sigma. So in this case, standard deviation, it is said to be the square root of the variance. So it is said to be the square root of the variance. So in that way, so this is how you should have to understand about the variance as well as the standard deviation. And the larger the value of the variance, the more the data is dispersed. You know, the same information we can depict from the mean deviation, it is the same information that the variance can give, and even the variance in the even the standard deviation can give also the same information. You know, all these tells how the data has been spread, you know, with respect to the mean of the data. So we'll be talking about we'll be talking about the grouped data as well as the ungrouped data. So keep that in mind. So let's start with the variance as well as the standard deviation for ungrouped data, the data which is not in the groups. So the formula that is being used to have the variance, it is given as sigma square is equal to the frequency times, you know, x minus x bar and overall to the power 2 divided by n, where n is said to be the size, should be the data. I can have it as a sample size. So it is given as the sample size. So this is given as the sample size, where this is given as the data value. So that is given as the data value, and that is the mean of the data. Should be the mean. By the way, we should have the summation here, and where f, that is the frequency. So f we say to be the frequency. So keep that in mind. And how about the standard deviation? Standard deviation, it is the square root of the variance, which is the square root of the summation of the frequency times x minus x bar to the power 2 divided by n. So have that. So those are the formulas that will be used and are basically for ungrouped data. So keep that in mind. Now let's say we have the following. Let's say we have the data that is given as 5, and let's say we have 10, and we have 15, and let's say we have 20, and that should be that we have also 5, and we also have should be about 30, like this. Now how should you have the variance as well as the standard deviation for this data? Mind you, this is ungrouped data, so we should have to understand that the formula that is being used to have the variance, it is given as the sigma square summation of the frequency, summation of the frequency times x minus x bar, and over to the power 2, and that is divided by, should be about n, where n is the sample size. So for this case, we should have to get it that n, it is given as, we have 1, 2, 3, 4, 5, 6. We have 6 values. So we have 6 values. By the way, we should have to, let me just have to eliminate single value here. Just have this. So we have about 5 values. So we have 5 values. So it should be that. So first thing, we should have actually the mean of the data. So what do you think would be the mean of the data? So now the formula for the mean, it is given as the x bar is equal to the summation of the values divided by the summation of, I should say, a summation of the summation of the values divided by the sample size. So in this case, how many values are here? So we have about, we should have the sum of, should be 5 plus 10, that is 15, and 15 plus 20, that is 25, and 25 should be 35, and the 35 plus 5, that is 40, and 40 plus 30, that is 70. So we have 70, and that divided by 5. So what is 70 divided by 5? So what do you think would be that? 70 divided by 5, that is 14. So in this case, it means the mean is given as 14. And from there, we need to present the table. So our mean is given as 14. We should have it here. So in this case, the mean, which is the x bar, will be given as 14. Then looking at our formula, looking at the formula that we have, we need to have the table that shows that this is the, that shows the x values, that is the data values, and we should have the mean somewhere, and we should have the frequency somewhere like that, and we should have the deviations from the mean, that is x minus x bar, and we should have the square of the deviations from the mean should be that, and we should have the column of the frequency times the squares of the deviations from the mean. Let me have this problem in this case. So we should have the column that shows frequency times squares of the deviations from the mean. So that is the table. That is the column, by the way. So we have the first value, which is given as 5. And what is the mean? We have it as 14. How many 5 values are here? We have them as 2, that is the frequency. Then we should have 5 minus 14. And that is, should be negative 9. And negative 9 to the power 2. So what would be that? So we have it as a positive 81. So mind you, as you are pressing this on your calculator, you should have to include the brackets into the power 2. Then I will have 81 times 2, which is the frequency. So what would be that? So in this case, we have it as 162. Then now we have the another value which is given as 10. And the mean remains the same, which is given as 14, and 10 minus 14, that is, should be, we have a single 10, which is the frequency. We have it as 1. And then 10 minus 4, that actually 14, that is a negative 4. And we have the negative 4 to the power 2, that is positive 16. And 16 times the frequency, it is the same as 16. Then we have the another value, which is given as 20. So the mean remains the same, which is 14. And 20 minus 14, that is should be 6 here. But the frequency, it is the same as 1. And what is 6 to the power 2, that is 36. And in this case, we should have 36 times frequency, which is 1. We have it as the same as 36. And we have the another value, which is given as 30. And the mean remains the same. We have that. Then the frequency is 1 as well. So what is 30 minus 14? So 30 minus 14, it's given as 16. So it should be 16. And 16 to the power 2, you know, it is given as, should be 256. Then 256 times 1, it is the same as 256. And from there, we should have the summation of this column. That will give us the value of n. So in this case, we'll have that one as, should be 5. So that is the value of n. And we should have the summation of this column. So that will be given as the summation of f x minus x bar to the power 2. So what would be that? So we have 256 plus 36 plus 16, that is plus 162. So that is given as, should be 470. I'll write that. And now we can be able to have the variance. So what do you think would be the variance? So in this case, the variance, which is the sigma square, you know, will be given as, that is 470, and divide by, that should be 5. So which is the same as, what is that divided by 5? We have it as 94. So that is what we get as the variance. And how about the standard deviation? Standard deviation is the square of the variance, which is given as the square of 94. So what is the square of 94? That is now being given as 9.5. It should be 7. So that is to the 2 decimal places. And that's how you should have to understand that an app. And by the way, some books, they actually represent n as being the same as the summation of the frequency. It is the same as that. So since we are having the sum of the frequency, so it is the same as that. And what if we have the following data values? How do you think we can have that? Let's say if we have the data which is being given us, we have it as, let's say 3, and then we have, let's say 5, and then we have 8, and that is 2, let's say half 4, we have 11, and we also have the 9 in this case. So how do you think we can have the variance as well as the standard deviation for the data? You know, principle remains the same. First thing, we need to understand that the values, how many values are here? We have 1, 2, 3, 4, 5, 6, 7. Now there are 7 values. So we have about 7 values. Then we should have their summation. What is the summation of the values? So in this case, we have them as, 3 plus 5. 3 plus 5, that is 10, and 10 plus this 10, that is 20, and 20 plus 4, should say 20 plus 11, that is 31, 31 plus 4, that is 35, 35 plus 9, So what is 35 plus 9? That is given as 44, or have it as 44. By the way, let me have to add the values again properly. We have that as we have, this is 8, of course this is 16, and 16 plus 2, that should be something about 16 plus 2, that is 18, and 18 plus 4. What is 18 plus 4? So we have it as 22, and 22 plus 11, so 22 plus 11 and plus 9, that should be 42, not 44. That should be 42, not 44. So I'll have it as 42. Like that. Then we can be able to have the mean, which is the x bar is equal to, we have 42 divided by 7, which is the same as 6. So which means the mean of the data is given as 6. So have it as, should be the x bar being given as 6. Then we should have to present the table, that is the x values, and we should have the mean, which is the x bar column, and the frequency, and we should have the deviations from the mean, we should have that one, then the square of the deviations from the mean, we should have those, and the frequency of the square, and the frequency times the deviations from the mean squares. So we should have that. So we have the first that is being given. Now let me just have to arrange them in ascending order. So have 2, and the mean is given as 6, and the frequency is 1. So have 6, actually 2 minus 6, that is given as negative 4. In the square, that one, that is, we should have it as 16. And 16 times 1, that is the same as 16. And then we have 3, and the 3, and the mean remains the same, that is 6. And the frequency is given as 1 as well. And the 3 minus 6, that is negative 3. And the square that, and that is given as 9. So in this case, 9 times 1, that is the same as 9. And we have, should be 4. And the mean remains the same. And the frequency is given as 1. And 4 minus 6, that is the same as negative 2. In the square that one, we have it as 4, and 4 times 1, that is 4. Then we have another value, which is 6, and the mean remains the same. Actually, another value, which is 5, and the mean is given as 6. Now 5 minus, so frequency is given as 1 as well. And 5 minus 6, that is negative 1, and the square that one is positive 1. And 1 times 1, that is the same as 1. And we have another value, which is given as 8. And the mean is 6, and the frequency is 1. And 1 to the power should be 1. It should be 8 minus 6, that is given as 2. And 2 to the power 2, that is given as 4. And 4 times 1, that is 4. And we have something about 9. So a 9 minus, so should be frequencies given as 1. In 9 minus 6, that is the same as 3. And should be 3 to the power 2, that is given as 9. And 1 times 9, we have it as 9. And finally, we have 11. And the frequency is given as 1. And 11 minus 6, that is the same as, should be 5. And to square that one will be given as 25. So 25 times 1, that is the same as 25. So keep that in mind. Then what will go up next? We should have we should have the summation of this column. So that is the value of n, we have it as 7. And we should have the summation of this column as well. Let me just have to present that on properly. So in this case, we'll have it as the summation of, in this case, we'll have the summation of, to the power 2, which is the same as what is the summation of this column? So we have negatives, actually positive 16 plus 9, and that is a plus 4 plus 1 should be. And by the way, if we have the sum of that column, you know that column will give us the summation of, and that should be 68, or have it as 68. So in this case, the variance, which is sigma square, will be given as 68, and I divide by 7, and which is the same as 9.71. That is due the 1 decimal place. And how about the standard deviation, or half the square of this? So keep that in mind. So here's the question for you. Do you think we are to square the deviations from the mean? Why should you have to square the deviations from the mean? And I try to have the summation of this column. What is it that I'm going to observe? So I want to see the responses in the comment section below. So why are we supposed to square the deviations from the mean? And what have you observed if you have the summation of the deviations from the mean? And now let's say we have the question, given that the data value is given as 2a, 3a, as well as the a, has the standard deviation, I should say has the variance of, let's say, given as 4. So what do you think is the value of a? So given that the data value is 2a, 3a, as well as the a, has the variance given as 4, what is the value of a? So try that question as well. And let's say we have the data values given as, let's say, y minus 2, and we have, let's say, y minus 1, and we have y plus 1, and we have y plus 2. Let's say this is the case. So we should have the variance as well as the standard deviation for the data. So how do you think we can have it? So in this case, principle remains the same. So as it stands here, there is no any other possible way we can have to evaluate the value of a first. So let's just have to use the same principle. So we have the number of values which is given as 1, 2, 3, 4. So we have it as 4. So the number of values given as 4. Now we should have the mean of the data, so which is given as the x bar. So x bar is given as, so what is the summation of the data values? So the summation of the data values, which is the summation of x, it is given as, so in this case, let me just have to present that on properly. I should have this as this. So the summation of the values given as y minus 2 and plus y minus 1 plus y plus 1 and plus y plus 2, like that. So in this case, we'll have the like terms, y plus y plus y plus y, that is 4y. And negative 2, negative 1, that is in negative 3. And negative 3, positive 3, that is 0. So we have the summation of the values given as 4y. And now we can be able to have the mean of the data. So what will be the mean of the data? So the mean is given as the x bar, which is equal to 4y divided by 4. Now the mean is given as, and it should be y, that is the mean of the data we have. And the next we should have to present the table. That will now be given as the x value, that is the data value, and we have, we should have the mean like that, and we should have the frequency, and that should be that. Of course, if the data values are occurring, let's say, are having the frequency of 1, so you may not have to present the frequency table. That is according to the way you can have it, but principle remains the same. And we'll have the deviations from the mean, that is another column, indirect that, and we should have the square of the deviations from the mean, that is another column, then the frequency times the square of the deviations from the mean, that is another column. Of course, the mean is given as it should be y, that has to be noted. So the mean is given as y, you can have to present that in advance. And the first value is given as y minus 2. Then the frequency is given as 1. Then we have y minus 2 minus y. So in this case, this y and this y will cancel. We'll have negative 2. And the square negative 2, that is positive 4. And a positive 4 times 1, that is 4 as well. That is. And we should have the another value, which is y minus 1. And the frequency is given as 1. Then we'll have y minus 1 minus, it should be y. So this one will cancel. We just have the negative 1. In the square that one, that is given as the positive 1. So 1 times 1, that is the same as 1. We'll have that. And we'll have the another value, which is y plus 1. So in this case, we'll have y plus 1 minus y. So in this case, this one and this one will cancel. We'll just have, should be 1 here. And of course, the frequency is given as 1, like that. And 1 to the power 1, that is the same as 1. And 1 times 1, that is the same as 1 as well. By the way, it should be that. Then we should have that as, y plus 2. So the frequency is the same as 1. Then y plus 2 into minus y. In this case, this one and this will cancel. We'll just have 2 here. In the square that one, that is the 4. And we'll have 4 here as well. Then we'll have the summation of this column. That is the n is equal to 4. We also have the summation of this column. That is the summation of the frequency times the deviations from the mean square. So in this case, we have 5, 6, and we have 10. So in this case, we'll have here 10. Then what do you think will be the variance? Now the variance, which is the sigma square, will be given as 10 divided by should be 4. And what is 10 divided by 4? It has to be, so 10 divided by 4, it should be 2.5. So I have it as 2.5, like that. And what is the actually standard deviation? So it is the square of 2.5. So what will be that? So we have it as 1 point. Should be 1 point. Let's say 581. That is to 3 decimal places. So that's how you should have to understand that now. And how about, let's say, if we have this question, how do you think we can have it? Now let's say we have this kind of the question that shows the data set in which we have the column for frequency and the column for the data value. So in this case, it is showing the frequency in which each data value occurred. In this case, we have 4 whose frequency is 0, and we have 2 whose frequency is actually 1, and we have 1 whose frequency is 5. We have 2 with the frequency 2, 6 with the frequency 3, and 5 with the frequency 7. So how should we have the variance as well as the standard deviation for this case? Now, when it comes to this case, principle remains the same, only that how do you think we should have the mean for this data? Now the mean, which is the x bar, it is given as the f of x, summation of f of x, fx divided by the actually n, which is the same as the summation of the frequency. Keep that in mind. So in this case, it means we'll have 0 times 4 and a plus 1 times 2 should be that until we have the sum of those. So we can just have to present the table just to make things look great. So in this case we can have x, and I'll have, let's say, the frequency like that. Then you can have fx like that. And since we are aiming at having even the standard deviation in the variance, we just have to present that one. So in this case, you can also have x minus, let's say, x bar. We can have that, and the x minus x bar should be square. Then frequency, x minus x bar square, like that. We can have even just that. So in this case, we have the x value, which is 4, and what is the frequency? 0. What is fx? That is 0. And we also have 1, that is, we have 2. So in this case, what is the frequency for 2? We have it as 1. And what is 1 times frequency? Actually, 1 times 2, that is the same as 2. And we have the another value which is given as 1, and 1 times 5, actually frequency is 5, and here we have 5. And I also have 2, and the frequency is 2, 2 times 2, that is 4. And we also have that, and as it should be 6, and 6 times 3, actually frequency is 3, that is 18. We just have to so in this case, we'll have it as, we have 7, should be 5, that is the data value, that is 5, and the frequency is given as 7, and 5 times 7, that is 35. So we just have to sum this actually column, that will be given as the summation of fx. So what is the summation of fx? So 2 plus 5, that is 7. 7 plus 4, that is 11. And 11 plus 18, and plus 35, that is 64. So have 64 in this column. And what is the summation of the frequency? So the summation of the frequency is given as, we have 6, and 6 plus 2, that is 8, and 8 plus 3, that is 11, and 11 plus 7, that is 18. Now in this case, the mean of the data, which is the x bar, will be given as 64 divided by 8. What is that on 64 divided by 8? It should be 18 rather. That is given as 5.6. That is to 1 decimal place. That is the mean. Then it means the cell we should have it. By the way, we should also have to present the column for the mean. Let me just have to square some space here, but that we can provide we can have the mean. But of course, first of all, we can have the mean first without even presenting the whole thing. We can have to have the mean first. So for this case, since we have the mean, then we are safe. Then we can just have to remove this one. Then I will have now the x bar, and I will have the deviations from the mean. We'll have that one. and we'll have the square of the deviations from the mean, and we'll have the frequency times the square of the deviations from the mean, like that. So everything will be done accordingly. So we have 3.6, 3.6, 3.6, and everything will be done the way we have discussed about. So that's how you should have to understand about how we can have the variance and the standard deviation and for the actually ungrouped data. So now, how about if we have actually the grouped data? So how do you think we can have the variance as well as the standard deviation whenever the data is grouped, the one which is in the groups? So the formula remains the same. That is the variance, which is sigma square, will be given as the summation of the frequency times. Now in this case, we'll have the xm, which is the midpoints of the classes, and the minus x bar to the power 2, and that divided by, that is divided by the summation of the frequency, of which this is the same as n. And we should have to understand that the x bar for the grouped data, it is given as the summation of the frequency times xm, which is the midpoints, and divided by the summation of the frequency. And the midpoint, which is the x subscript m, is given as the upper value and plus the lower value divided by 2, and for the given class. So let's see how we can have that. Let's say if we have the data, that is the grouped data rather. Let's say we have the classes given as, should be that, and we have the frequency. Let's say it is given as that. Let's say the classes starts from 1 to 5. So you should also have to recall on the, sometimes you can be given the data that you need to present that one, that you need to present it in the actually a frequency distribution table on your own. So you need to have that skill on how to do it. In case you may need of that skill, just have to refer to my actually video playlist on the YouTube channel. Come across this, all these things, how to construct the actually, how to construct, and that should be, let me just have to stop there. So how to construct the frequency distribution table, that is like that. So we have the frequencies actually given as 1. Here we have 3. Here let's say we have something about, let's say we have 4. Here 10. Let's say this is 6. So now how do you think we can have the variance and the standard deviation and for this data? So we should have to understand that the first thing, according to the formula presented, we should have the mean. So by the way, we should have the midpoints first. So we can just have to have it as xm, that is the midpoint. Then we should have fxm, that is that. So this information will help us to have the mean of the data. So in this case, for the first class, this is the lower value and this is the upper value. So have the summation, that is 1 plus 5, that is 6, divided by 2, we have it as 3. And the 3 times the frequency, which is given as 3. And they have 6 plus 10, that is 16, divided by 2, that is 8. And the 8 times 3, that is 24. We'll have that. And 11 plus 15, so it should be 11 plus 15. So it should be 11 plus 15. What is that? We have it as 26. And I divide by 2, that is 13. Then we have 13 times 4. So that is 52. And we have 16 plus 20, that is 16 plus 20. So how do you think would be that? So 16 plus 20, that is 36, divided by 2, that is 18. And 18 times 10, that is 180, like that. And what if now for the for the next class, that is 21, and plus 25, that is 46, divided by 2, that is given as, should be 23. And how about that one times, should be 6, or have that one as 138. So like that. Then we have the summation of this column, that is the n, that is the summation of the frequency ladder. We should have that one, or it's the same as the n. So have 1 plus 3, that is 4, and 4 plus 6, 4 plus 4, that is 8, and 8 plus 10, that is 18, and 18 plus 6, that is 24. And what is the summation of this column, which is the summation of fxm? So in this case, we have 3 plus 24, that is 27, 27 plus 52. So 27 plus 52, and plus 180, and plus 130. That will be given as 397. So I have it as 397. So in this case, the mean, which is the x bar, is given as 397, and divided by 24. So that is how you should have the mean, and for the grouped data. So in case you may need the detailed structure about this, you just have to refer to my video playlist. You come across all these things. Just have to refer to my video playlists. You come across all these things. Then now we can be able to have what we call it as the variance and the standard deviation for the data. So how should you have it? In this case, let me just have to structure another table presenting the information. So in this case, we can just have to, now we have the xm. Now instead of the data values, like the way we had it before in the ungrouped data, we'll have the xm, that is the midpoints. That is the midpoints. Then we'll have that one as a frequency. We'll have the frequency here. Then we'll have, we already have the column for frequency. Let me just have to transfer this here. So have the frequency somewhere here, just that. And we'll have, we already have the mean. Of course, let me just have to put this one here. Let me just have to transfer this one as well. I'll put it here like this. Then that is, then I'll have the mean, that is being given as, that should be, what is the mean? So what is the mean there? So 397 divided by 24, that is a 16.5. So the mean is 16.5. So have that 16.5, 16.5, 16.5, 16.5. Then I wish to have another column as usual, that is x minus x bar, that is the deviations from the mean. And I wish to have another column for the square of the deviations from the mean, and also the frequency times the deviations from the mean square. We'll have that. Then everything remains the way we are doing on the ungrouped data. So we have the first value for x. So in this case, we'll have it as x. We should have m here, subscript m. That is the midpoint. So have that. Then everything will be in the same way, like the way we did it before. So try to have the variance and the standard deviation for for this data. What if, let's say, we have the data, which is given as, let's say we have it as 1 to 10, let's say that is the case, and whose frequency is given as 2. We have 11 to 20, whose frequency is given as 7, and let's say 21 to, let's say, 30, whose frequency is 10, and let's say 31 to, let's say, 40, whose frequency is given as 3, and 41 to 50, let's say the frequency is given as 1. So try to have the actually a variance and the standard deviation for that data, and also try to have the variance and the standard deviation for this data. Let's say we have 19 to 29, let's say that is the case, 29 to 34, let's say the frequency is given as 10, 5, and let's say 34 to 39, the frequency is 2, let's say 39 to 44, let's say the frequency is given as 10, should be 12, and now we have, let's say that one as, let's say 44 to 49, let's say the frequency is given as, should be 7. So try to have the variance and a standard deviation for the data in that way. And now, as I already said, that sometimes you can have the data, that is, you need to have it in the groups, then you should have to calculate the actually, you should have to calculate the variance as well as the standard deviation. So you should have to understand how, you should have to refer to my video that I explained about how we can have to construct the frequency distribution table. Then from there you'll be able to have it. Thank you.